All right, I'm going to get us started. Hello, everyone, and welcome to today's Illinois Green Alliance virtual workshop, Embodied Carbon Lifecycle Analysis Tools, EPIC, Tally, and EC3. This is the last of our 2024 High Performance Design series of longer workshop formats to engage presenters and attendees alike and dive deeper into some decarbonization tools. My name is Miranda Wright. I'm the Education Engagement Manager here at Illinois Green. I'll be going through some quick logistics, an overview of Illinois Green, and then pass it over to our wonderful speakers today. You have all been muted upon entry. At the end of today's presentation, we'll have some short time for Q&A. We'd love for you to put some questions in the Q&A function as we go for the presenters to respond as we go along. But at the end, we'll allow people to raise their hands and unmute you to ask your question live. For those who are unfamiliar, Illinois Green Alliance is a member-driven nonprofit organization that advances green buildings and sustainable communities for all. Our 5-year strategic plan pushes the green building industry to meet or get on the path to net zero. We achieve this work through educational events such as today, by engaging communities and partnering with organizations across Illinois, and by advocating for new policies and legislation. I also want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, USGBC, and Sloan. Make a commitment to advancing green buildings in communities across the state and start the conversation with sponsorship. And now I am extremely excited to introduce you to today's presenters. Katie Poss is the Director of Global Policy and Procurement at Building Transparency, the developers of the EC3 tool. In this role, Katie supports the nonprofit's core mission of providing the open access data and tools necessary to enable broad and swift action across the building industry and in addressing embodied carbon's role in climate change. Prior to joining Building Transparency, Katie served as Director of Sustainability Initiatives at the National Ready Mixed Concrete Association and as Sustainability Program Manager at Turner Construction for its data center portfolio. She is a board member of the California Straw Building Association and serves on New York State's Embodied Carbon Technical Advisory Group. Vaclav Hasik is a program director at Building Transparency. Vaclav works on methodology, data quality, and LCA research supporting Building Transparency's tools. He was previously a sustainability analyst and lifecycle assessment expert at Urban Fabric, where he managed projects pursuing LEED certification and helped design teams address embodied carbon through whole building LCAs. Vaclav also worked as a researcher at the University of Pittsburgh, where he was involved in university-wide carbon accounting, sustainability planning, and research on data and methods for LCA of buildings. Thank you both for taking the time to talk with us today about your amazing tools. I will now stop sharing my screen and pass it off to Katie.
Awesome. Thank you, Miranda. I really appreciate you having us today. And thank you all for showing up for this deep dive 2-hour training. Today, we're just going to be starting with an overview. Let's see here. Can you see my screen in presentation mode?
Yes, looks great.
Yep.
Okay. We're going to start with an overview of the existing tools in the ecosystem, even looking at some briefly beyond EPIC, TallyLCA, and EC3. And looking at the typical workflow and phases of a construction project and where each of these tools might be most suitable to use throughout the course of a typical construction project. Vaclav will then take it over and talk about EPIC and how and when to use that tool. And then he'll be giving a demo of TallyLCA. And then I will wrap us up with a demo and explanation of EC3. And then hopefully we'll have some time at the end for Q&A. But I encourage you, if you have questions as we go through this, drop them into the Q&A function. And then we may have some time at the end for live questions if you'd prefer to ask your question live. So just a little bit about Building Transparency. We are a Washington State 501c3 nonprofit based in Seattle. We are a small but mighty team of 5 full-time staff, and we work with third-party software development partners to support EC3 and TallyLCA We are all remote. I'm calling in from my home office here in Western Kentucky, just outside of Nashville. Vaclav is in the Bay Area. We've got a staff member in Colorado, and then our executive director is in Seattle. Our core mission is really to provide open access data and tools to support the building industry with addressing embodied carbon and other environmental impact indicators beyond embodied carbon in the case of TallyLCA. We'll talk a little bit more about that later. As a nonprofit, we would not exist without the support of our partners and sponsors who are shown here on the right of the screen. We work with a very diverse group of stakeholders across the AEC industry, everyone from large tech companies and developers who are using our tools to support their Scope 3 emissions accounting and to estimate the embodied carbon of their building portfolio, and specific the building materials that they're using. We also work with general contractors. We host a number of carbon action networks. We have manufacturers can, owners can, and contractors can, where we engage stakeholders who meet monthly and discuss best practices and lessons learned and case study. It's really just a forum for sharing and supporting each other with tackling embodied carbon and how to quantify it and how to reduce it. So just jumping in here, I want to give you a workflow that you could follow, especially using the 3 tools that we are talking about today. When it comes to Epic, this is really beneficial at the conceptual phase. When you're just analyzing different building components, deciding whether or not you might want to build with mass timber or a concrete frame or steel. And Vaclav is going to go a little bit more into detail on that. It's especially useful if you're analyzing the impacts of a new build versus retrofit, analyzing the impacts of the location and the shape of the size of the structure. But getting into, as we advance through the drawing progression of a building project or an infrastructure project, as we get deeper into design, this is where TallyLCA, also Athena's impact estimator, one-click LCA, those are the 3 most common whole building LCA tools on the market. And they really assist with that design option comparison and understanding the impacts of system X versus system Y, and looking at multiple environmental impact indicators, not just GWP or embodied carbon. And then when we advance through the drawings into procurement, at this point, the design is pretty much baked. We're not going to be able to make any significant changes to the design. But this is really where the construction partners, the GCs, the subcontractors, the material suppliers, they're starting to get awarded contracts and start to be onboarded to the project. They now have access to the drawings and the specifications. And this is where EC3 can come into play, where you can look at the materials that are specified, look at materials that are locally available, especially in the case of ready-mix concrete and asphalt, understanding which material manufacturers have published EPDs in your area, and starting to look at some of the products that have been specified and determine which of them has a lower carbon footprint, and really using EC3 to inform procurement. So as I mentioned, there is an entire ecosystem of tools, and there are more emerging every day. Tally, one-click, Athena, really those whole building LCA tools. There are tools that meet specific needs or pertinent to specific systems or materials. SE 2050's Ecom tool is really focused, as you could imagine, on structural design and structural elements. Bentley is really focused on infrastructure. Epic and CARE and Sustainable Minds, there is a whole slew of tools on the market, and they are used for different purposes and serve different functions. If you're familiar with the life cycle stages of a building project, EC3, specifically the find and compare materials feature, will really support you with understanding the product stage impacts, also known as A1 through A3. A1 refers to raw material supply. I have a background in concrete, so when I explain this, imagine, limestone being one of the primary ingredients to make cement. You have to get that limestone out of the earth somehow. So extracting those raw materials and mining operations would fall under A1. A2 would be transporting those materials to the point of manufacture, and A3 would be the manufacturing process itself. So these environmental product declarations, which are the public-facing summary of an LCA, disclose the environmental impacts of manufacturing materials, and it tells us one indicator in particular, that's that global warming potential metric, which is synonymous with embodied carbon. We also have modules A4 and A5 in EC3. This can help contractors and project teams estimate the emissions associated with transporting materials from the point of manufacture to the job site. And then A5 would be associated with activities that are actually happening on site to build the building, excavation, temporary power, things like that. Right now, EC3 is limited to these life cycle stages, but just a glimpse into the future, we are working on adding some of the B and C stages, and eventually EC3 will be a whole life carbon tool. When it comes to Tally, Athena, and Epic, being whole building LCA tools or whole life carbon tools, as I just said, they incorporate the use phases. So these are associated with activities like replacing materials over time. Think of a hotel and how often they renovate their rooms, replacing carpet, painting, replacing, patching drywall. Activities like that are associated with the use phase. And then also looking at the end of life. What's happening to these materials when their useful life is over? Unfortunately, a lot of times buildings are demolished before the buildings have reached the end of their useful life. So the hope here is that we're able to reuse those materials to some extent, recycle, and as a last resort, dispose them into the landfill. So as you can imagine, we can calculate or estimate with a reasonable degree of certainty those A1 to A5 emissions, because they happen before we ever turn over a building to an owner. When it comes to the B and C stages, however, whole building LCA tools help us to estimate and predict what those emissions could be in the future based on certain scenarios. And Vaclav is going to get into that later. So why do teams run an LCA? Well, there are a lot of drivers. Policy is a big one, both public and private policy. We're seeing a lot of activity in the policy landscape, not only here in the US, but globally. I just saw this morning that Ireland is prohibiting the use of CIM1 cement, which would probably be most similar to our ordinary Portland cement or type 1-2 cement, which has the highest amount of clinker, which is the primary driver of carbon emissions. So they are banning the use of that, highest carbon cement altogether on state-funded projects. Buy Clean is a term you might have heard here in the US. Buy Clean California, I believe, was the first. Buy Clean Colorado went into effect in January of this year, and Buy Clean, Buy Fair just passed in Washington State this year. And these Buy Clean bills typically are setting GWP limits or thresholds for specific material categories that project teams must meet for state-funded projects. There are also various internal commitment programs or external commitment programs and benchmarking efforts. SE 2050, MEP 2040. The CLF is conducting their whole building LCA V2 benchmarking study now. And it's really useful for project teams to share their data publicly to the extent that they're able to support these benchmarking and aggregation efforts so we can better understand what the true impacts are of the built environment and drilling down into different building types, hotels, data centers, these are all different types of buildings and they'll likely have different benchmarks. And then finally, there's a number of certifications that require or have credits available for project teams that conduct a whole building LCA or conduct an embodied carbon study. After some of you have reviewed the LEED V5 draft and submitted comments, there was an evident emphasis on embodied carbon and whole building LCA and whole life cycle impacts. So for projects that are pursuing LEED or ILFI zero carbon certification or Living Building Challenge, you may need to use these tools to support achieving those credits. So it's really important when you're starting out with a whole building LCA or any embodied carbon study, LCA study at all, to first determine what systems that are going to be included and modeled. Sometimes we see just structure being modeled. It's common for just structure and envelope to be required, but we're seeing more requirements advocating for the inclusion of interiors. There's also furnishings and equipment, MEP systems. As you can imagine, in data centers, MEP data servers and hardware and all of that equipment probably has a very big impact, but there's not a lot of EPD data available yet, or LCA data yet, to disclose the impacts of some of that MEP equipment. We're starting to see some of that change, and I'll show you in EC3 a little bit later some of the MEP specific categories we have built out. And then sometimes site work, hardscapes are included, sometimes they're not. It's really important to be clear and disclose what is included in the model and what is not. Then you need to understand what environmental impacts you need to quantify or estimate. Global warming potential, as I mentioned before, is that greenhouse gas effect, that primary driver of climate change, and essentially synonymous with embodied carbon. So when we talk about embodied carbon, and when you're looking at an EPD, you're going to be looking at that GWP metric. But there are other environmental impacts disclosed in EPDs, and that tools like Tally can help you to quantify. Eutrophication, ozone formation, think smog and all the transportation emissions from shipping materials all over the place. Acidification and ozone depletion. These are all other impacts that are not good for the environment, but that these tools can help us to quantify and to better understand. And then finally, you need to understand the scope of each sub-analysis. Are you just looking at material substitutions, comparing carpet product A versus carpet product B, or drywall A versus drywall B? Are you modeling and looking at an assembly? In the case of a wall assembly, you need to consider things like stud spacing, wall depth, how stud spacing and wall depth are impacted by different insulation selections, how different insulation selections impact the sheathing or the waterproofing membranes that you might need. So really looking at a full assembly side by side is another thing that LCA can help you do. And then finally, the full building analysis, which is what Vaclav is going to be demonstrating with EPIC and TallyLCA. With that, Vaclav, I don't know if you want to share your screen. I'll let you take it from here.
Sounds good. Just give me a second to switch my screens here. All right, so we'll walk through these tools as if we were going through the building design and construction process. So we'll start with the one that addresses the early design stages, the conceptual and planning stage. So this tool, epic.ehdd.com, that's the best tool that I know of that's openly accessible, that can help you with some of those early designs or the early assessments before you actually have any sort of 3D models or material quantity takeoffs put together yourself. So this is a free tool that you can register for. Once you open the tool, this is one of the landing pages. You can create a new project and walk through a couple of steps of just defining the basic parameters of that building project. So for example, we'll just go through an example test here, and we'll define or describe obviously the name, year of completion. Those are not necessarily critical for the calculations, but they help you put building in context. Location, so I'm in Oakland, California. And then you can define the baseline structural system. So this is going to be kind of your first analysis of what a building of a particular type and size, what the carbon footprint of that project might be. And we'll say that we are working on a K through 12 school as an example, and we'll keep that baseline structural system as a reinforced concrete system. There are a couple other predefined system types that you can select from. Finally, the last step here really is the number of floors. So let's say we have 3 floors, and let's say we have 10,000 square feet per floor area. So 30,000 total. Once we finish that, you can see that immediately we get an estimate of total emissions, including embodied carbon, operational carbon, and then if we were using any sort of wood-based products, or if the structural system was, let's say, mass timber, you would actually see carbon storage as well. And so you can see that just by describing the general type of building, I can quickly get an idea of what typical projects of this size and type, what those impacts are, both an embodied and operational carbon perspective. This tool is using historical data to come up with these estimates, and it also considers different types of assemblies and the ranges of impacts that are represented in a large set of data set that EHDD architecture worked on essentially collecting data for. Now, this is the initial way of understanding the potential carbon footprint of a project of this size, but there's also additional features that the tool allows you to do, and that's come up with not just the baseline scenario, but some other alternative scenarios. So I think at the beginning, it does ask us for the base case. We'll just keep on refining this one. We'll save the base case here. Not sure why it's not letting me. Okay, 0. All right, so that base case has been saved. Now we can go and define additional cases. So we'll go into reduce emissions. We can create a new scenario. We can copy the current scenario and then start modifying various aspects of the building design. So here we have test scenario 1 copy. Say this is scenario 2. And then we can start modifying, let's say, are we reusing part of the structure? We can actually move and specify the percentage of that structure that was reused. We can do the same thing for roofing and other systems on the building. And over time, you will see that the results on the right side actually start changing, and they show you some of the potential differences in the embodied carbon and operational footprints that some of these decisions might make. So let's say we were reusing all of the structure, put that structure reuse at 100%, wait for the project to update. And you can again see how that line for the embodied carbon emissions specifically has reduced. So it's really hard to see right now. There's a faint difference. There's sort of a white part of the bar chart here that shows you those embodied carbon emissions over time. There's also a better way of actually looking at those comparisons. So we'll save this scenario. Actually, it auto saves. We can go into the compare section. And now we can show the baseline scenario and the other test scenario side by side. You can see again embodied and operational emissions, as well as potentially stored carbon emissions if those were relevant. There's so you can see again different ways of showing those differences in results. In this case, the operational impacts actually overpower any of the embodied carbon impacts. So you don't see a whole lot of changes here, but this is a nice tool that again, you can use very early in design to just kind of evaluate basic understanding of different types of projects, structural systems, reuse aspects, etc. You don't have to have detailed material quantities. So that covers planning and conceptual design. Now, if you are later in design stages and you actually start putting together let's say a building information model, that's where you would typically go in a little bit more detail. So
Hey,
we'll open
Vaclav,
up. Yep.
there
Other
are
questions?
maybe two quick questions on Epic. How are Epic's estimates validated?
Good question. So they are based on actual material quantities collected on projects, and they combine those material quantities with carbon footprint data from sources including EC3 and some other generic data sets. In terms of how the impacts are actually validated, I don't know. This is not a tool that we develop. So I assume there should be some discussion of this in the Epic documentation. And if not, I know Jack Rusk, who is the developer behind this tool, he's also very responsive. So we can provide you with, contact information. You could reach out to Jack at EHDD.
Great. And this might be a question for Jack, but do you know what the avoided emissions are based on?
I think, is the question about the reductions? I think that's the question, right? So if you have reduced emissions, in our case where we, for example, defined that the structure was reused, the avoided emissions are essentially removing the amount of carbon that it would normally take to manufacture or to make some of those materials that were reused from scratch. There's some additional options that you have here in how the reductions are calculated. It's always taking into account the differences in the production emissions, or even use phase replacements emissions between the different scenarios that you set up. Does that answer the question, or was the question about something else?
I think so. I'm not sure. Maybe we can save that one for the end and let Martha elaborate.
Sounds good. And I see there was a question about what happened to test scenario number 2. Good question. I thought when I renamed it, it actually changed the name, but it didn't seem to help. Oh, here it is. Okay, sorry. It's been a while since I used the tool. So now, when I defined test scenario number 2, it actually was shown here. That's why we weren't seeing some of the results or reductions in impacts, because test scenario number 1 was the exact same copy of the initial baseline. So apologies for some of the confusion here. I hope this makes a little bit more sense now that we see test scenario number 2. Avoided emissions mean different things to different groups. Yeah, but hopefully in this context, that explanation helps. All right, let's move on to the next step, and that would be one more question. Is there a tool that could be used in other countries other than the US and Canada? Currently, I think there's at least one tool. It's not open access, I don't think, as the Epic tool is. Epic tool really focuses on the US-based market. That's where the material quantities are related to. There's OneClick has I think it's called Carbon Designer tool, which does something very similar. And that one is actually, that one includes data from Europe primarily. I don't know if they actually have North American data. They might, but that one would be more globally applicable. So you could do something similar with OneClick Carbon Designer. All right, if there are no more questions on the early stages, let's move on to the next stage. So let's say we are in schematic design development, where we're actually starting to put together some sort of building information model. And we'll talk about building information models specifically here, because our TallyLCA tool is a Revit plugin. There's also a way to do this kind of analysis without having a Revit model. Katie will go through the EC3 tool later on, which doesn't require you to have a Revit model. You can simply input material quantities an EC3 tool can also be useful, during early design stages. It's not just a procurement tool. So I'll leave Katie to also explain some of those ways that you can use EC3 during different stages of design. Now, if you're an architect specifically and you are using Revit, I think TallyLCA should be pretty helpful to you. It really streamlines the process of assigning material information as well as the environmental impact information to your building information model. You can download TallyLCA for free on choosetally.com. There's a 10-day free trial. Otherwise, you would have to purchase a commercial license if you wanted to use it after that free trial. But once you install the tool, it will show up here under the add-ins section. And this colorful TallyLCA logo, that's how you launch the tool. And the tool first downloads all of the material information in its library, as well as all of the environmental impact information that you can then select from. At this point, we can select the type of study that you would like to run. I will walk mainly through the full building study, but you can also define different design options in your Revit interface and do direct comparisons of the impacts of different. They can be as simple as material substitutions, but you can also set up entire assemblies that you can then compare to each other. And then you can also do and use TallyLCA with the defined template file. If you don't actually want to assign materials just to physically placed elements throughout the model, you can go and assign materials to your template, where you assign materials to all of the families that you may be using as part of your firm, sort of standardized set of families. And then anyone that uses your predefined template subsequent to that wouldn't actually have to go and define the material types themselves. They would simply start placing things in space and immediately essentially be able to assess the carbon footprint or life cycle assessment impacts of that project. Excuse me. So to show you how the tool works, we'll go into the full building study section. And the first step, again, to Katie's earlier point, is to define the scope of the analysis. Here you can see all of the Revit categories that the tool can handle right now. It's really focused on the structural and envelope systems, as well as some of the major interior components. It does not cover things like MEP systems. You can also select, include, or exclude elements based on the work sets that they are placed on. This is especially helpful if you, for example, have interiors that are actually part of the envelope or within the building. For example, for LEED purposes, you can choose to include or exclude some of the interior components that are not immediately connected to the envelope system. And so there may be a way of differentiating which elements are included or excluded just by based on which work set they might be placed on. You can also include or exclude elements based on which phases they were created in. So if you're working on an adaptive reuse project, or you have a project with multiple phases, you can also include and exclude elements based on that selection. And then TallyLCA also does allow you to assess impacts of linked models. So in my case, in this case, I have a structural model, which is a separate model, just linked into the currently opened one. And you can assess the impacts of those linked models as well. So in my case, I'll just select all of the scope here, click on apply. Now the tool is looking through the entire model, collecting all of the dimensional information that's available. This is essentially equivalent to doing a material quantity takeoff table that you might be familiar with within the native Revit interface. But here, TallyLCA is doing it itself. Okay, on the next page, now we have all of the elements and all the families within all of the categories that we've selected all populated. And in my case, I'm actually looking at a model that has been previously worked on. And so you can see that most of the Revit categories are this green color. That means that someone has already gone in and assigned all of the material definitions to all of the elements. Now let's take a look at a couple of examples of how you actually go and define some of the material information, or how you assign environmental impact information to the individual elements. We'll take a look at some of these walls that have not been defined yet. For example, we have this generic concrete family. So I'll open that one up. And that family only has one layer, and that's the cast in place concrete layer. If I wanted to see where this object is in place, I can right click it and select elements. And then if I move this over, you can see highlighted where those elements actually are within the model. You can also isolate in the Revit view to be able to better tell where some of those elements are located. On the right side here, you can see the material quantity takeoffs that Tally was able to get from Revit. So we have the total wall area, wall perimeter, and the wall length. And those would be some of the dimensional information that is then used to calculate the actual material quantity at the end of the day. Okay, now if we click on this layer, we see that this area here is blank. That essentially means that we haven't actually assigned any material impact information to that element in the TallyLCA tool. So what we have to do is right-click that element, click on Edit Definition, and then find the material type in the Tally library. So in our case, this was a cast-in-place concrete, so we'll go into Concrete Division, Cast in Place, and there are a number of predefined types of concrete that you can choose from. This was a wall system, so I will assume that it was probably maybe 4,000 PSI strength. And I can click on the Apply button, or I could right-click and click Apply here. The next step that you need to do in TallyLCA is provide some additional information about either the source of that material or some additional performance characteristics or description of the material type. So in the concrete case, you have options of different amounts of supplementary cementitious materials that you can choose from. We also have the NRMCA regional benchmark values that you can choose from here. So if you're just coming up with, let's say, a benchmark building design with all the benchmark values, you might be able to select one that is applicable to your particular region. Normally, if you don't really know which one to select, the first one is the most generic data source selection that you can choose from. So in our case, I'll do that. I'll say this is a 0% supplementary cementitious type of mix. You'll see that automatically a couple of the other fields are getting auto-populated with information. That's additional information that is necessary for the tool to be able to do a actual realistic material quantity takeoff. In the concrete topic, or for the concrete material, it's actually pretty straightforward. You just take the full volume of that element and you connect it to the concrete material data within the tool. There's no sort of nuanced additional types of information that you might need to specify. There is an additional accessory material that you can add to this element, though, that may not actually be modeled within the building information model. And so Tally will always tell you about the potential accessory materials that might be relevant based on the fact that you've selected a certain type of product, like cast-in-place concrete. So in this case, there's probably some reinforcement needed within the cast-in-place concrete wall. We'll select the first most generic data set for the reinforcing rod. And then here, the takeoff method will actually be slightly more complicated. You can either use a predefined typical amount of rebar that there may be per unit of concrete element, or you can also define the takeoff method by spacing, and you can say exactly what type of size of rebar you have. And then do you have one-way or two-way spacing? Do you have perimeter member rebar as well? And then you would define what type of spacing there is. So let's say it's 10 inches between different rebar sections. You can specify that here as well. This information will then be combined with the wall area that is put in place, and it will calculate an actual realistic amount, realistic quantity for the amount of rebar that there may be in that wall section. So at this point, we could go and save those definitions, and you will see that now the area here in the bottom right corner is populated with the general product type that we selected, and then the individual subcomponents of that product type. So we have structural concrete, 0% fly ash, and we have the steel reinforcing rod. There's 950 kilograms of that steel reinforcing rod that we selected. So this is how you assign material information to each element. It is the same process essentially for the rest of the project, but obviously different material types may have different drop-down menus for some of the takeoff methods. Once you fill in all of the material information throughout your project, you can go and save a report. And here you do need to fill out all of the fields. So I will just type in here, test, goal and scope assessment. Normally it's a good idea, or it's definitely critical for you to at least review the gross building area field and make sure that it accurately describes your project, because when you're generating the report, it will show you some of the environmental impacts per unit area of a building. And that is a good way of gauging the, first the validity of any of the results that you get, but it also allows you to then compare to other types of projects if you're trying to do sort of a portfolio benchmarking study. The expected building life will most likely remain at 60 years. That's the typical building lifetime that's used in these life cycle assessments. But you can modify this expected building life if you wanted to change it to something like 75, 100 years. It will affect the replacement impacts, some of the materials that may not last the entire lifetime of that building. So specifically some of the interior components. And then in the goal and scope of assessment, it's always a good idea to describe, which design phase you're working on this assessment. Is it an assessment for a baseline set of results, or have you already, assessed baseline before, and are you trying to see what certain changes to some of the material selections would actually, how they would change the results of the environmental impacts of your project? So it's always good idea to try and fill out pretty comprehensively what the goal and scope of this particular assessment is. There's some additional settings that you can modify. You can go and look at the transportation distances that the tool is using by default to assess the transportation related impacts in the A4 stage. You can also include or exclude biogenic carbon, but normally you would probably just include it. Just give you the option to potentially focus on fossil carbon in cases where that might be the requirement of the analysis. But by default, you will probably be including fossil and biogenic carbon. You can also include construction impacts and operational energy impacts, but this is not a tool to help you come up with those quantities of fuels or water or other resources. So you would essentially need to know what those quantities are and just simply input those quantities here, select the unit, and select the source type of either the construction fuel that's being used or the fuel that's being used in the operational energy impact space. So for example, if you did your energy model in another tool, you could enter the final quantity into TallyLCA here. TallyLCA is primarily useful really to help you understand the embodied impacts in the materials that you put in place though. So that's what we'll focus on here. Once you have all of this filled out, you can click on the Save button, and that will save out a report. It will save out a PDF report as well as an Excel report. And the Excel report itself might usually take about a minute to generate, so I'm just going to show you an example that I already saved out before. So we'll start with looking at the PDF report. This is what the report will look like. You can include an image on the front page of the report. Then you have some table of contents on the next page. And finally, page 3 will have your first set of results that you can go and analyze. I talked about showing environmental impacts per area, which is the most useful when you're trying to, understand if your modeling process was correct and also how this might stack up to other buildings. So it's usually a good idea to start looking at, let's say, the production stage, global warming potential value per meter squared or per area. And this value should typically be somewhere between 200 to 1,000 kilograms of CO2 equivalent on a new construction project. This is probably also the value that you can then compare to things like what you may get for embodied carbon footprint in the EPIC tool that we looked at earlier, and see how this value actually compares. When we go through the rest of the pages, you can start analyzing more granularly where some of the contributions to your building project footprint are coming from. So for example, here on the right side, we can look at the various environmental impact categories that Katie mentioned and quickly see what the contributions are from, in this case, different life cycle stages. So any of the red stages here are production stages, A1 to A3. Blue is transportation stages, so that's actually very minimal. It's hard to see here. Maintenance and replacement stages are in these turquoise colors here. And you can start in, taking a closer look at, okay, what are my biggest contributors? Where could I focus my attention to? If we keep going through this report, you can see additional, outlines of which types of materials contribute how much to each of the individual environmental impact categories. It may be kind of hard to sometimes actually connect the different shades of colors to the different bars. And so it might actually be more helpful to go and open up that Excel report for this particular project. So move that over here. This report has exactly the same data as is on the PDF report, but it actually allows you to see the specific values. And you can then also, extract it and modify it and create your own charts if you would like to. The structure of the report is exactly the same. So normally you would go and see what are the types of information that the bar chart in the PDF report would be showing you. And for example, if it's showing you the different divisions of materials and the different tally material entries that you've selected, you would go to the division tally entry tab. And here you can see that I can now actually see the global warming potential results for the different types of cast in place concrete that were used on the project. And so again, this is another way of going and understanding the contributions of different elements of your building to the overall project footprint. I think I will show maybe one more thing in the project report, and that's the back section of it. So there is the calculation methodology in the middle of the report that walks you through the methodology that the tool itself uses. It also includes descriptions of the various life cycle stages and environmental impact categories if you are relatively new to this topic. So you can always go back and reference it for your own understanding. In the LCI data section, this is where you get a list of all of the material types that you have actually selected on your project. And you can see which families they're used in, what are the mass takeoffs that TallyLCA has assessed based on the different definitions that you've defined within your building information model. And then it also has additional descriptions and some of the background methodological aspects that you can also take a look at. So this last section of the report is also another good section for quality assurance of all of your work. I think I'll take a step back inside of TallyLCA and show you one last thing before handing it over to Katie to talk about EC3, or actually to open it up to questions before I hand it over to Katie. So far we've assessed an entire project as a whole and just looked at one set of results and try to understand the contributions of different components or material types. Now you're going to be making decisions on what material types to use, or if there are actual design, systematic design alternatives that you can implement. So I'll go back into the define scope section and go into the design option comparison section. And in my case, I've actually defined a couple of different design option sets down here using the native Revit design option features. So if you're familiar with this feature, you can define different design options inside of Revit. You can then actually model those design options. So I'll show you an example of my design option for this different atriums. So this whole atrium, I have two design options, one with the butterfly roof and one with a flat roof. And you can also tell that the curtain wall system has slightly different setup in terms of the size of the individual windows and the layout, the mullions. So in this case, I can go back into TallyLCA and we'll do an option set comparison here for the butterfly roof and flat roof. Click apply. Now it's collecting, again, dimensional information for those two design options. And in my case, I've already gone through all of the materials and defined all of the, assigned all of the material types from the Tally library to my Revit model. At this case, I can go back to the save report and save out another report. And that report will look like this. So it starts off looking the same, except now when you get to page 3, you will actually see two sets of results for each environmental impact category. And so in my case, I see butterfly roof system, flat roof system, and you can see how they stack up side by side in each of these environmental impact categories. I can likewise go and take a look at some of the additional analyses. So let's say we are looking at divisions by tally entry again. I can zoom in and see the contribution of different material types to each of those design options. And I can start, better understanding of how that change in the whole atrium system may actually affect the overall impacts of that particular part of the building. So when you're doing these comparisons, it's always critical to make sure that you are comparing things that are functionally equivalent. So for example, in my atrium case, I assume that the energy performance on the entire building wouldn't actually change by doing those differences in designs of the atrium. And also that I am preserving the amount of floor space that is actually covered by that atrium is exactly the same as well, so that you can have the same functionality happening within that space. Those are some of the things that you always want to consider when you are doing these design options comparisons, is that the functional equivalency is preserved. With that, I'll open it up to questions from the audience before moving on to the next section, EC3.
So we've got one about the ability to add product-specific EPDs into Tally. And then how does Tally calculate materials if you select existing or salvaged options?
So the first answer is you can't add additional EPDs. Like if let's say you found one on the internet, you wouldn't actually be able to add it into TallyLCA natively. We are working on a next generation of this tool where we will actually pull more data, more environmental product declaration data from the EC3 database. It's not currently available in this version of TallyLCA. So normally what you could do is first, you could select a generic equivalent to that particular material type. You could generate the results here in the Excel-based, set of results, and you could actually reveal additional information in this table. So this is a pivot table. So I could go and click on pivot table analyze, open the fields list, and then reveal the life cycle stages. And in this case, I could substitute the A1 to A3 product information with the information on the EPD. Now, this is obviously a little bit more cumbersome. At this point, you would have to do that yourself. The tool doesn't do it itself today. There is one potential option for you if you are okay with just focusing on embodied carbon, just on the global warming potential side of things. There is a way of exporting your TallyLCA model into EC3, and then you could select a specific product-specific EPD inside of EC3. So essentially, you transfer all of the material quantities from your TallyLCA model, as well as the initial description of what the material is, and then you can refine that material assignment with the specific EPD information once you get to the EC3 tool. So that would be another approach. So that was the first question. Second question was, remind me, was that the reuse of materials?
Yep. How does Tally calculate materials if you select existing or salvaged options?
Right. So if you go and define or edit definition, so you have this aluminum mullion, there is this checkbox for existing or salvaged material. If you check that box, the tool will essentially remove the A1 to A3 product impacts from the calculation. Because it's assumed that if you are using a salvaged material, those production impacts have already been accounted for in essentially the previous life cycle or previous use of that particular element. It will still include the transportation impacts, the maintenance and replacement, and end-of-life impacts for that material, but it will remove the production-related impacts.
Great. We've got another one. I can take a stab at this. Are there any tools that cover MEP items? You mentioned Tally doesn't. I'll show you here in a moment. There is some EPD data for MEP, and we have some categories built out in EC3. Vaclav I guess Tally doesn't have any MEP data. Are we looking at that in V2 possibly?
Yes, we are. It's mostly dependent on there being information on the environmental impacts of making any of those elements. So that's one thing, and then the other one is using the material takeoffs from the building information model, and we are planning to address some of those in the V2 of this tool.
Great. Can multiple people work in the same Tally model? Follow-up question simultaneously.
So simultaneously, it depends. It just follows the regular structure of how you would be working on a model in Revit in general. So I believe it's been a while since I worked through the details of this, but if you are working on a work shared model, each person can check out a particular work set at any given time. And so you might not be able to work on the same work set simultaneously, but you could be working on the same model if you're working on separate work sets and you have those checked out separately. The main thing is that anytime you make material assignments inside of Tally, you always want to save and synchronize back to the central model that you started from at the beginning, because that's the only way that you actually preserve the assigned material information data, over time, and so that other people can later load the work that you've done yourself. All of the TallyLCA data is being written back into the model in extensible storage, and that's why you need to save and sync to the central model in order to preserve that work.
Great. I think that's it for the Tally questions for now. If you think of any later on, we should have some time at the end, but we're right on time. Thank you, Vaclav. Okay, I'm going to share a few slides and then we'll get into the demo of EC3. So what is EC3? It is, EC3 stands for Embodied Carbon and Construction Calculator. It is an open access digitized database of environmental product declarations and an associated building project planner that will support you with estimating the embodied carbon emissions, again, from those A1 to A5 life cycle stages of individual building projects. We do have an infrastructure planner that we're currently testing, and we're hoping to expand the use of EC3 to infrastructure projects as well. So with the basic formula for calculating embodied carbon and what's essentially going on in the back end of EC3 is multiplying a material quantity by the GWP or carbon factor of an individual material. So I'll show you that when we go over into the demo of the tool, but that's the basic math that's happening in the background. At a portfolio level, we do work, like I said earlier, with a lot of owners and developers, and there are some features that they have access to where they can generate roll-up reports and do some data analytics at a portfolio level. Just to give you a glimpse of the data that we have, I think these numbers have likely changed since I took this screenshot on July 8th, but at that time we had just over 150,000 valid EPDs digitized in the database. These are coming from 2,400 different companies or manufacturers. They're the ones who essentially disclose or publish these EPDs, coming from 5,000 different manufacturing plants. And we have built out 227 material categories in EC3. The heat map here shows you visually where this EPD data is coming from. EC3 started in North America, and as such, we have the most EPD data here, but we're starting to see that change globally. So as you can see here, we're seeing EPD data being published in multiple countries around the world. And just to note that these locations represent the manufacturing location of the material. You can see here that the growth of EPDs has definitely trended upwards over time, and we anticipate that growth to continue, especially with some of the EPA grant announcements that came out recently, and I'll talk about that a little bit later as well. Looking at our user base, as of July, I think we actually just reached our 50,000 user milestone recently. So we have over 50,000 active users of the tool, coming from 5,000 different companies, and a lot of architects. Architect profession represents our biggest user base, followed by construction, sustainability consultants, really the entire AEC industry, in addition to government and owners, have utilized and are utilizing the tool in some way. Reminder again, A1 through A5 are the stages EC3 currently calculates, with B and C stages coming in the future. Okay, I'm going to hop over. If you haven't done your homework yet and you would like to register for a free account to EC3, you can go to buildingtransparency.org and click this register free button. I am already logged in, and just a note that I am going to do the demo using my pilot account. The pilot was a paid subscription to EC3, and it comes with additional material categories, including those MEP categories that I mentioned before, and a few features that aren't available in the public free version. If you have the public free version, you'll likely see professional user next to your name when you've logged in. So just a quick tour of the home screen. Here's that nice heat map again, but here you can toggle between concretes and non-concretes. And again, the higher EPD count is represented by a darker blue color. And you can scroll through here and zoom into the United States. This is how we see EPD data broken out by county here in the US, concretes, non-concretes. If you're interested in EPD data in Europe, and then here's a bar chart. Ready mixed concrete definitely represents the highest count of EPDs that we have in the database by far. This is likely due to a number of reasons. One, the nature of ready mixed concrete, because it is so regional. I imagine Illinois and Chicago and the Chicago metro area, you have a number of plants servicing concrete to the Chicago metropolitan area. And from each of those plants, There could be upwards of more than 100 unique mixed designs at each plant. Each of those unique mixed designs has its own EPD. So that is one of the contributing factors to the high count of concrete EPDs that we have in the system. Another is that the concrete industry has really been talking about and focused on EPDs and encouraging the industry to adopt and publish EPDs for many years. I might be a little bit biased because I used to work at NRMCA, but they really have been on the leading edge of publishing EPD data and getting on board with transparency via EPDs. Okay, let's take a look. If you are just interested in seeing if a product has an EPD or if we have an EPD in our database for a specific product or in a specific category, you would go to Find and Compare Materials. And here you will see the parent categories. The ones noted as pilot are the ones that are available to the paid pilot partner tier. As you can see here, MEP. And if you expand any of these little plus signs, you can see the subcategories underneath each parent category. So as you can see, we've built out a number of mechanical, electrical, and plumbing categories. So if, let's just say, I haven't tested this out beforehand, but let's see if we have any data or EPDs for mechanical ducts. I'm going to then click the red EPDs button, and there are going to be a number of performance specification filters that appear that are specific to the material category you're searching in. I'm just going to keep my search terms very broad and then click search and click yes and see if we have any EPDs for mechanical ducts. As expected, we don't have many. We have one here. This EPD is published by Veltec as the manufacturer. You can see here there's a description of the product, and here is the GWP. If I click this open button, this opens the digitized EPD entry in EC3. So what happens when people upload PDF EPDs, which is the most common format for publishing EPDs? We have computer systems that parse and read the flat PDF and attempt to digitally convert it into this format. Oftentimes, there might be some errors that require human intervention, and we have people that work to review the parsed EPDs and make corrections where necessary to ensure data quality. But one thing that we are really working on is working with program operators and EPD generators to promote a digital-first publication of EPDs. It's time that we evolve beyond the flat PDF publication of EPDs, and we do have a digital EPD schema that's available that some of the major program operators and EPD generators like Climate Earth and WAP and Smart EPD have adopted, to where they are automatically pushing data into EC3's database and to other databases, which really reduces the risk of human error or computer error in that PDF to digital transition. If you want to see the actual PDF EPD, if it was published in that way, you can click this button to download the EPD. And it will initiate a download, and we can take a look at the original EPD here. Let's take a look at another material category, and perhaps we'll do it within a building project. If you click on Plan and Compare Buildings, you'll be able to see first under My Buildings, all of the building projects that you yourself have created. There are also a number of templates here. This includes building projects that the general public has opted to publish that you could peruse and see if there are any interesting projects, perhaps similar to one that you're working on, and just see what all they included in their model. There are also a number of templates that we've created. There's a New York State policy reporting template, as well as a New York City policy reporting template here. So I encourage you to take some time to take a look through the template projects. Under Shared with Me, this is where you will see any building project that someone has shared with you. So as the owner and creator of an EC3 project, it is automatically by default private to you. No one else can see it. We do not share building project details publicly without your explicit permission. And you can choose to share a model and collaborate within that model. And I'll show you how to do that here in a moment. But these are all of the projects that have been shared with me. Here are those public projects that people have opted to anonymize and publish. And then all buildings would be basically the sum of every folder above that. So I'm going to show you an example project that I've already got open. If you want to create a building project from scratch, you'll just click plus building project here. And then you can either start with a blank project or start from a template. And this is what it looks like if you start from a blank project. I'm going to show you a demo project that I already have populated. First, entering basic project information such as the name. You can specify the building use type here. You can also enter the floor area above and below grade. And then if the building project has multiple use types, you could specify those here. Let's say 10% of it is mercantile or some kind of retail store, but 90% of it is office space. You can associate a percentage of the overall square footage with each use type, or you can enter the actual square footage or square meters if you're outside of the US that is associated with each of these. Click done. You can also enter the construction start date here. Just a note that the construction start date is tied in some ways to the EPD results that you will get. We tried to show you EPDs that are valid and not expired on or before the construction start date, excuse me, on or after. So I'll show you what that looks like here in a moment, but just know that this construction start date, by default, you will see EPDs that are valid after the start of construction. We don't want to show you expired EPDs that have expired before you started construction. You'll enter the address here. It's tied to Google Maps. Here is a project tags feature. This is a feature that is just for pilot users, but you can customize tags here. Let's say you're collaborating with somebody and you want to let them know that this project is ready for their review. You could just assign the ready for review tag. Here's a notes and links section. You can use this for whatever you want. You can also link attachments, maybe drawings or things like that here. And then there's also project classification fields that are not required, but are encouraged to the extent that they're useful to you and to the extent that you know this information. You know, what level of development are the drawings at the time that you conducted this assessment? What is the source of the material quantities? What is the source of your A5 quantities if you are entering A5 data? What's the scope of the construction project? Is it new? Is it a renovation? Or is it just looking at the interiors, maybe a TI project? There's some fields to enter the primary horizontal gravity system, primary vertical gravity system, podium, if there is a podium or not, primary lateral resistance system, foundation system, seismic design category, and risk category. Here, this is where it gets back to that defining that scope piece. Are you just modeling the structure? Are you modeling the structure and foundations? Is the enclosure included and our interiors included? I believe I have all 4 of those below, but we'll check. We do have a simple embodied versus operating feature. You can enter the operational energy use intensity here and then specify the percentage associated with natural gas if it uses natural gas in any way, and then specify the percentage associated with electricity, and then select the most closely corresponding grid or selection here from the dropdown. And then here is just another place where you can enter that floor area above and below grade. You can enter the number of stories and the height here as well. So scrolling down here, this is the calculator portion. This is where the meat and potatoes happens, as I like to call it. By default, you're going to be here on the A1 through A3 manufacturing tab. A4, you can toggle over. Those are those transportation emissions from the point of manufacture to the job site. And then A5. In A1 through A3, you have a number of options in how you want to view and structure your material entries. By default, it will be in uniformat. You can choose to toggle over to master format if you want to organize by CSI spec division. And there's also a custom tab, which you can use and organize them however you want. If you click here, you can replace this text with anything you want. I'm going to stick with uniformat. And as you can see here, I already have a number of materials populated that are included in the foundations. If you want to add a new element under the foundations, you'll click this plus button, add new element. You'll override this text and enter a description of the material. And then you just hard keyed in that description, but EC3 doesn't know what this material is yet. So you have to tell it by doing something called what we call mapping the collection. You'll do that by clicking on this red search button. And this probably looks familiar. This is the exact same interface that we just looked at before with find and compare materials. Let's say this is another concrete mix that's being used on the foundations. So I'm going to navigate to ready mix concrete and then click search for EPDs. Let's say because this is a foundation mix, it's probably a relatively higher PSI. Let's say it's 6,000 PSI. Just a note on units, you can enter imperial or metric. EC3 will do the conversions for you. It recognizes megapascals, though it's probably not going to be 6,000. It also recognizes PSI. There are a number of different performance specifications here. I'll specifically acknowledge the default for lightweight aggregate is no. So what we're going to see here is all the mixes that do not include lightweight aggregate. Manufacturing lightweight aggregate contributes somewhat significantly to the overall embodied carbon of a concrete mix. So we keep those separated, just like you've probably seen in the NRMCA benchmark report and some of the policies that have established GWP limits. They have separate thresholds and benchmarks for mixes that include lightweight concrete or lightweight aggregate. If you want to see the mixes that have lightweight aggregate, you can just click on this again. And when it says yes, you'll only see the mixes that have lightweight aggregate. If you want to see them both, we'll just leave it unselected. But by default, it's going to be no. When it comes to geography, my approach to this is it depends on the material. With ready mix concrete, you want to search within the state, and even better, you want to search within probably a certain mile radius from your job site. If you're looking for a specific EPD, you have, it's been submitted on your project, this specific mix from this plant is being poured on your project. What I would recommend is to specify a maximum distance from the project site. So this is tied to the project address that we entered before. And let's say I only want to see the mixes that are within a 50-mile range. Let's see what we get and then click search. Okay, so when the box plot and whisker chart appears here, that's when you know that the search results have completed. I'm going to scroll down and we're going to take a look at our results. So the industry EPDs are hidden by default, but you can expand those here and see. And then the product EPDs are all of the product-specific EPDs that met our search criteria. So there are 182 product-specific EPDs for a 6,000 PSI concrete mix without lightweight aggregate within a 50-mile radius of our project site, which I think was in the DC area. You can further narrow your search results by manufacturer. Let's say you know that Cheney is supplying your project. Just click Cheney and then click out of the box. And in theory, that should only show me results from Cheney. Appears to not be working right now. I apologize. Okay, usually that works. I'm not sure why it's not working right now, but test it out later. Hopefully it's just a minor bug that will resolve quickly. The planter plant group is listed here. So this is where, especially in the submittal phase, when you're conducting an EC3 model based on as-built information, typically I would have the project submittals pulled up on one screen, have the EPD that the subcontractor submitted on one screen, and then have EC3 open on the other. And this is where you can verify on the EPD, okay, this is an Ernest Meyer mix. It's coming from the Baltimore plant, and it's mix B65305. Just make sure to verify that the information is the same. And another way to do that, just to double check, is to, again, open the digitized EPD, open the original, make sure that it matches the EPD that was submitted to you on the project. Let's say we confirmed that this is the correct entry. We are going to select this EPD. By clicking selected, you'll know that it's selected when it turns the teal color and it moves to the top of the list. And now I'm going to click use this collection. So now you'll see here that my foundation concrete mix for 6,000 PSI is populated. These little chips here represent the collection, the category, and the other specification filters we just defined. And then you'll see the EPD that we just selected here. Next, you will enter the quantity. Let's say we use 1,500 cubic yards of this mix. You can change the units there, enter the quantity, and as you can see here, my numbers changed. This is the realized value of embodied carbon. So what's happening is that we're multiplying the volume by the GWP from the EPD that we selected. Now I want to go back and explain something in a little more detail, and that's this box plot and whisker chart. And one thing you'll notice is that when we selected the EPD that we did, you can see how that EPD compares to the rest in the category. I'm going to hop back over to my slides and explain this in a little more detail. Okay, so the box plot and whisker chart will show you the range of GWP values based on the search criteria that you enter. The top bar here is the maximum GWP. The bottom here is the minimum. Those are the outliers. The top of the green box represents what we call the conservative value. This means that 80% of the EPDs based on our search criteria have an embodied carbon or GWP lower than this value here. In this case, it's 760 kilograms of carbon dioxide equivalent per cubic meter. This achievable value at the bottom of the green box is what we define as 20% of EPDs found have an embodied carbon at or below this value. In this case, 410. You can also choose to set a reference line. We do have the CLF baselines 2019, 2021, and most of the 2023 industry average lines built into EC3. I believe, I'm not sure if it's available in the professional tier, but in the pilot tier, you can also customize and move that purple line wherever you want. Let's say you want to compare it to the NRMCA regional benchmark value, or maybe you're working on a GSA project and you need to see where your EPD falls in reference to the thresholds that they have established for, let's say, their top 20% value. So you can move this purple line route around. It's just a reference line. Now, I want to explain how we come up with these statistics. We don't just evaluate the product-specific EPDs and include them in the statistics for the box plot and whisker chart. We also include the impacts of the relevant industry-wide EPDs. and we include those, we weight them more heavily than a single product-specific EPD. We do have publicly available methodology and how we determine these statistics. So if you're interested in diving deeper there, we can provide a link to that. Okay, I'm going to jump back over to the live demo. Okay, so in this example, you'll just continue that process for adding every material that you want to include in your analysis. Again, remember, you can use this button to add a new element. You can also add a new subassembly like this. Let's say you have some basement construction materials you want to model. And as you can see here, I have a pretty extensive model filled out. So once you've entered and defined all of your collections, you've assigned the EPDs to the extent that they're available to you. Let me talk through that. If you're doing the EC3 model before procurement, before you actually know what products are being used, you don't have to select an EPD. You could simply assign the collection without selecting any specific EPD. What's going to happen in that case is that if you do not select an EPD, the realized value will default to this conservative or 80th percentile value. In this case, it's 407. So if I just simply click use this collection, you'll know that I haven't selected an EPD because there's no manufacturer and description below the collection. So what's happening is this is, again, defaulting to the conservative value in the absence of an EPD. As you enter quantities and as you assign collections, the embodied carbon totals are going to roll up and sum up here. And we show you the results as a range. We're not showing them to you as a single deterministic number or value. We're showing you the achievable, what we think you can get this project's embodied carbon down to based on the 20th percentile of available EPDs. The conservative value is that, again, that 80th percentile value. And then your realized value is based on the actual EPDs that you select where you have them. So we have the totals here, and we also have the intensities and communicate that in kilograms of carbon dioxide equivalent per square foot. If you're working on a project outside of the US, you can toggle to metric if you wish. You can toggle back to US units. Make sure you save your work. There is no autosave feature in EC3. If you close out of your browser tab, you will lose your work. I would recommend saving your work if you've entered several materials and mapped collections and spent some time entering data. Just hit that save button every once in a while just to be safe. This is where I wish I had that Jeopardy music. Okay, while that is saving, I'm going to hop back over to my slides and talk through just a couple more things here. Let's talk a little bit about specifications and sort of the workflow when it comes to embodied carbon on projects and some resources that we have available to support, especially designers. If your client is asking you to incorporate embodied carbon into the specs in some way, we do have some example specification language posted to our website. We're seeing this become more and more common where there are requirements to submit EPDs, even for non-lead projects. And even in some cases, specifications are establishing a target GWP. And this is where, for those of you who work in the concrete space or are familiar, if you're a structural engineer, even outside of concrete, there is a trend and a desire to shift towards performance-based specifications. Thinking back to my time at NRMCA and at Turner, oftentimes you would see in specifications where they may be very specific and prescriptive in the way that they're specifying certain mixed designs. For example, I've seen where there is a maximum, a cap on a percentage of fly ash replacement or slag replacement that's allowed in the specifications. And that, in my opinion, unnecessarily prohibits or limits a ready mix supplier and a concrete supplier from doing anything they can to reduce embodied carbon. If you are just arbitrarily or conservatively putting a cap on a supplementary cementitious replacement material, that could be limiting their ability to reduce the embodied carbon of their mixes. So what performance specifications do is they try to give you the performance that's needed for the specific mix and application, but strip out some of those sometimes unnecessary prescriptive requirements, which could inhibit innovation and inhibit from the ready mix supplier from doing what they do best, which is designing mix designs. And a lot of them are getting better now at optimizing mix designs for reduced embodied carbon footprint. Policy compliance filters. Let's see if my project has saved. We have implemented a number of policy compliance filters in EC3 to support those of you who might be working on a Buy Clean California project. We also have the Cal Green prescriptive pathway limits, FEMA and GSA IRA limits, and Buy Clean Colorado, which just went into effect in July. So let's pop over here. Great, our project is saved. I'm going to see if I can show you what those policy compliance filters look like. So that will appear as a compliance dropdown. And as you can see, there are a number of options. In this case, I'm going to apply the filter for Buy Clean Colorado, greater than 8,000 PSI, lightweight, no, and then click search. And what the search results are going to be the EPDs that fall at or below the GWP threshold and compliance with Buy Clean Colorado. One more thing I wanted to show you, if you want to share and collaborate on a building project, by default, this button here will be red and say private. Click on that, and then you can share this project with others. You can do that by searching for their name, and then click add. I think I've added all the Katie Posses I can here. Let's say I want to add Vaclav. I'm going to click on his name, click add, and then by default, his permission level will be read, meaning he can view the building project, but he can't touch it. He can't make any edits. You can assign write permissions, and if you hover over throughout the tool, there are a number of tooltips built in to help you understand what each function will do. In this case, write means that he can edit the document, but he cannot delete it. And manage means he can change the permissions that other users have. And in theory, I think he could also delete the project. Then click done. And now my project is shared with others. And again, that project, once you share it with them, will show up in their shared with me folder, not their my projects or my buildings folder. To wrap this up, just to give us some time for questions, I want to show you quickly what some of the reports and charts look like. I guess the primary report that we often demo, and you might have seen when other people are talking about EC3, is the Sankey diagram. And what this shows me is visually at a glance where the embodied carbon is in my building project. And what this does is it helps me to focus my efforts on those materials and those assemblies that are going to give me the biggest bang for my buck when it comes to procuring lower carbon materials. The ready mix in this case is contributing most significantly to this project, the precast concrete. In this case, the blanket insulation, the fiberglass insulation, based on the quantities and the EPD or selection that we've used, is not really contributing significantly to the overall embodied carbon of the project. So in this case, we should really look at optimizing these mix designs and procuring or using a lower carbon mix where possible. And then this rolls up to the right to the overall building level. And this R represents the realized value based on all of the EPDs that you've selected. So you can see how well your realized result is doing relative to the achievable. In this case, we are below the CLF baseline. We are a little bit above achievable. We could probably do a little bit better, but we're doing pretty good. And if you hover over, you can see what those exact results are. We also have the lead bar chart if you are working on a project that's pursuing the lead procurement of low carbon materials pilot credit. We've got some reports and exports that support you with that credit. Under reports, you have to save before you can run a report. Looks like I made a minor edit there. While that's loading, let me just take a peek at the chat. Yes, you can use this for projects in Latin America. As far as language translation, we are working on that. Some of our enterprise partners do have language translation abilities available. I'm hoping soon that we'll be able to push that out to the public version of EC3, where you can change the language of the user interface to Spanish and multiple other languages as well. So hopefully soon. How to open the templates, cannot open the dropdown.
Yeah, there was an issue with the setup. I changed it and you should be able to see it now if you refresh the templates page.
Okay, great. If you have quantity takeoffs, can you use EC3 for the whole building LCA per lead? No, you cannot. That credit requires calculation and reduction in more than just GWP and more life cycle stages, but you can get that pilot credit that I just mentioned for up to 2 points. And I believe there will be more emphasis on embodied carbon models in LEAD V5. Is there a program? Might be best suited for single family residential, smaller scale residential. You can use EC3. We've worked with some residential builders to use EC3. There's also the Beam tool, which is really great for single family residential. It's also free. So I encourage you to check that out or use EC3. Okay, I think that's it for now. Let me show you some of these reports quickly. The most common one that we typically see people use is this building element report. Got it open here. So this is going to give you, there's a lot here. It's going to give you results in Excel format, basic project information here, name, and then here's a list of all of the elements that are included in your building project, the quantity, the reference line, if there is one established, the conservative value for each individual material, and then the total for the project here. And then here's the emissions intensity per square foot, the realized based on the EPDs you selected, or the conservative value if there is no EPD, reduction from reference calculated here, and then the achievable values. There's also information about the product EPDs that you've selected and a link to the digital EPD entry. I'm realizing now that we did not look at A4 and A5, so let me just quickly show you. If you toggle over to the A4 calculator, a lot of this work is done for you. What we're doing is especially if you select an EPD, we know the manufacturing location from the EPD, and we know the location of your job site from the address that you've entered. So we do some of those calculations for you and conservatively estimate the A4 emissions impacts, which are shown here. Under transport, though, you can go in and refine the mode of transport, which will have some impact on the calculations. In the case of ready-mix concrete, the default is mixer truck. 9.5 times out of 10, that's how it's going to get to your job site. But for things like steel or other materials that are shipped in different ways, if it's procured within the US, maybe it is getting there just from a truck on one leg. But if it's coming from overseas, it could be coming by ocean freighter or ship first, and then by truck. So if you know that level of detail around how the materials are getting to the job site, you can specify the mode of transport and the distance of each leg here. And then finally, under A5, this is where you could enter a description of the activities. In some cases, coming from a contractor background, we would collect this data on a monthly basis from each subcontractor. So I might say steel fab, October 2024, fuel or diesel. You actually don't need to say that because we're going to specify it here in the input type. You then select the fuel or electricity that you're entering, and then select the quantity here. Let's say they use 50 gallons of diesel in the month of October. Okay. Vaclav, am I missing anything major? Anything else you think I should demo for the group?
No, I think that's it. Although there was another question, I may have missed this, but if you are working on a portfolio of projects like a campus, can you nest buildings or show combined numbers?
Good question. Let's look at that. I'm going to go into my buildings. And in this case, this is a folder structure you could set up for this specific scenario where you might have a campus ABC, and then you could create subfolders underneath there here and call it buildings East Campus or something like that. For whatever scenario that best suits your needs, you can create a super folder, subfolders underneath that. Can you nest buildings or show combined numbers? You can select multiple projects here, and then you can click roll up reports. And you have a couple of options here. You can do the formatted project elements report. In this case, it is being generated and will be emailed to me. So yes, you can generate roll-up reports for multiple buildings for a portfolio.
You can also select this icon. That is the icon for the roll-up report as well.
Oh, great. I've never actually used that. Nice. Cool.
In TallyLCA, it's not exactly defined this way, but I guess if you had a Revit model for all of your buildings, you could link them all in a campus project Revit model. I don't think I've seen anyone do that before, especially because sometimes it can cause performance challenges to Revit when you have a lot of things in a single model. That would probably be one way of doing it. I would normally just instruct anyone that is working on a building or a campus, if they were using TallyLCA, to share the Excel report with you, and then do the campus-wide accounting from aggregating the data from the Excel reports. That would be my suggestion.
Yep. Let me try one more thing and see, show the comparison feature that's relatively new. Within a building project, you can do comparisons to other projects. Ran into this before, which was what I was hoping would not be the case. For some reason, I have 0 values here for this project. So I might have to demo this one at a later date. I realize this is new, and I think we've got some bugs we're working through on this feature. So we'll save that for another time. I do have just a couple more slides to wrap us up here, and then if we have more questions, happy to take them or wrap up a little bit early. So ultimately, you need to define what your end goal is, And I recognize that the more that embodied carbon becomes a requirement or request by owners or a public policy or lead, in some projects, you might actually need to meet the needs of multiple different schemes or certifications or policies. So it's really important, first and foremost, to understand what the requirements are that you need to meet for the project and what your end goal is out of the whole building LCA or embodied carbon modeling exercise. Just a couple of tips here from a workflow and process perspective. It's important to determine team roles and responsibilities. Who is the lead for embodied carbon modeling? I was on a webinar earlier today, and an architect from ZGF had a great visual where, sometimes the structural engineer will be the lead for the whole building LCA, but everybody needs to be involved in this process. It really doesn't need to be done in a silo. So I love the questions about, collaborating and sharing within the same model. Make sure everyone on your team is aware of the requirements. Talk about it. I remember, working for a GC, and sometimes those requirements wouldn't trickle all the way up to the leadership on the project. So just make sure to talk about it and make sure everybody is aware. Ask subcontractors and material manufacturers to bring their ideas to the table. They are experts in their specific materials, and they can really help advise on what strategies are suitable for your specific project, especially if they're brought in early. Ask for type 3 product-specific EPDs to be submitted at time of bid so that you can try to do a more granular analysis in EC3 in tandem with procurement and use it to help make some of those procurement decisions. Ask for low carbon alternates to also be submitted with bids. Think of this exercise as carbon value engineering. This way, the owner and design team and the project stakeholders can evaluate lower carbon alternatives or strategies with cost and carbon side by side. And then oftentimes we see that whole building LCA and embodied carbon estimates are done in design, and we meet our goal in theory, but we don't actually document if that's what happened out in the field. For those of you who have worked on construction projects and been on, especially working with contractors, you know that change orders are very common. Scope creep is a thing, and quantities, especially if you're adding concrete or if you have to demo something because it wasn't poured correctly and you have to re-pour. It's important to really capture what actually happened and what was installed on site, because those are the real emissions, not the theoretical emissions. And then finally, if you're interested in becoming an EC3 pilot user, we can drop this link in the chat, but we just launched this. Historically, pilot access has been reserved for corporate sponsors, but we just launched an individual pilot access tier. You'll get access to those additional material categories. You'll also get access to quarterly open office hours with our team and access to some of those features that are not available in the professional tier. And we'd really love not only your support as a nonprofit, but for you to inform the future development of EC3 by providing feedback and having a direct link to us and our team. And then there are a number of resources available on our website, the user guide, some recorded demo videos, and specifically an EC3 tips document for GCs. I would also encourage you to use the report bugs and feedback button in the bottom right hand of your corner of the screen in EC3. If you have a question or you encounter a bug, our entire team receives those, and we try to respond as quickly as possible. So I think that wraps it up for us today. Happy to open it up to any more questions in the last 10 minutes that we have here.
Great, thank you so much, Katie. For those still on, if you would like to be unmuted, you can raise your hand and ask your questions to our speakers, or you can still put in questions in the chat. Either way, we are here to answer what you got. And if we don't have any additional questions, we just put in our feedback survey also in the chat. If you can give us some feedback on this format, this information, we would love to hear kind of how this type of format is working, and see if we want to do more of it. Is there anyone who wants to be unmuted, ask your questions? Okay, going once, going twice. All right, I would love to thank so much Katie and Vaclav for your guys' time, your expertise, these tools. This is now the second time I've got to see you all present on it, and it's amazing. And there's so much going on in there, and I hope people are able to use it and soak it up as much as the rest of us have. So thank you again, and we will see you next time. Goodbye, everyone.
Awesome.
Yes, we'll have a
Thanks, everyone.
recording. Bye.
Thank you.